Hi, thanks for joining us today. Today we're joined by Dr. J. Patrick Kennedy, founder and CEO of OSIsoft. Hi, Pat. Thanks so much for joining us.
Thanks for inviting me, Megan.
We're also joined by John Matranga, the Director of Business Incubation and Acceleration. Hi, John.
Hi, pleasure to be here.
Thank you for joining us. I'm Megan Lehtonen, the Market Principal for Government Relations and Community, and we wanted to take some time to talk with Pat about global warming. So, Pat, you recently wrote a couple of papers on solving global warming with Pi and the mitigation of global warming with IoT and AI. The Pi system, of course, has a major role to play in the mitigation of global warming. Can you explain that a little bit more to us? Explain the importance of the Pi system within this and the foundational infrastructure. If there are 20 things, and one being AI, that all need reliable data quality, what does that look like, and how can we leverage software and sensor data to address how it might be used to reduce the amount of GHGs in the atmosphere?
One thing that struck me is I came across a paper by our EPA that identified exactly where the generation of greenhouse gases was coming from. And as people would expect, it was the big players, the transportation, electric utilities. And then as we looked more into these industries, we could see a lot of them were designed to run independently. And in so doing, they consumed a lot of energy just to be able to be independent. For example, are in the power business and you want to supply power to the wall, there's only one reliability and it always has to be there, which means if you just need a little bit of power, you still have to fire up a plant. You still have to produce that power, and that independence is very expensive to run. So where I saw the actual information becoming useful is that that's really a disruption in the information flow, because it didn't know it was going to need the extra power and it didn't know how to get the power. So they actually purchase very small, fast-moving assets that cost them quite a lot of money. Basically, that's where the data come into it. You can't really run optimally unless you, first of all, know where you are and know where you need to be. And thirdly, you actually take action.
Thank you. So, Pat, you know, there's so many encouraging solutions that are coming out around AI and the potentials here. What's necessary to ensure data quality into AI and other applications and solutions? I've heard you explain it before as AI being the shiny race car that everybody wants, but we all know that we need the highway built for those cars to optimize performance on. Can you talk to us a little bit about this foundational layer as a prerequisite to AI? What do we need to know to get there?
It's a big question. Getting the data and getting it in properly for what's expected by the application has been a challenge. So I can give a couple of examples there. One would be if you look within a facility, you look at the informational needs of an operator versus the informational needs of a maintenance person. An operator or operations, they basically are trying to have stability throughout the transient for material and energy balances, 2-3 days, something on that order. If you look at the maintenance people, they're looking for a cause and effect, a fault that may have caused a piece of equipment to fail, but they're looking at the same data. So if you're producing production reports, then 30-minute averages, that's fine, 5-minute averages, whatever you pick is very adequate for that. If you're trying to supply the same information to maintenance people, they're going to want to see every bit of resolution you have, because they want to be able to see the thing that actually caused the fault. AI is simply an extension of that. Let me say that was human intelligence, but really the data needs of AI is the same. Because it's remote, it has to be accurate, because taking action on inaccurate data is actually known to be a real problem in the industry. And it has to be of the right fidelity expected by the application. So if your AI is built around, let me say, 5-minute averages, you have to furnish it cleansed 5-minute averages that you feel are as good as you can make them. So that's really just an example of what happens in the data world and why you need an infrastructure, because you really can't state a priori what your data needs are. And they're all looking at the same point, but each of those cases, they needed the data in a different format, different fidelity, and you need one system of record that stores everything.
Excellent, thank you. And you mentioned before when you were talking about the paper on the mitigation of global warming, you broke it down by industry. If we just were to focus on the modern grid and renewables, what do you see for us in the future within this space?
So we think that renewables are the future. So we put in very large solar, we put in wind, we put in rooftop solar as well as solar farms. And what happens is when the sun goes down, they stop producing. Or when a cloud comes over, they stop producing. Or the winds pick up and they start producing. In other words, you don't really know how much power you're going to get out of them. They're not dispatchable resources. And so what the power company has to do is they have to balance that with a dispatchable resource. So if the wind picks up and you're generating huge amounts from your wind farm, you have to back off on your production. Or if you have a lot of solar production, the same. Or if the solar production goes away, you have to bring that up, and you have to bring it up as rapidly as it went away. So clouds are worse than dusk. So everything is based on time. What this does for you is it forces you as a power company to shift your assets from really high efficiency turbines that might take a day to line out to smaller turbines that respond in a matter of minutes. And as a result, your efficiency drops. Now let's take it and let's jump the meter. So on the other side of the meter, you have people that are trying to cope with the power issues with blackouts, rolling blackouts, etc. So they put on rooftop solar and they put on maybe batteries, because the new batteries are now dropping in price very, very rapidly. And some of them even have their own windmills that sit in the middle of the complex. The problem there is that those are not managed by the grid, nor are they predictable. And so now the power company has to bring in extra power, extra resources to be able to cope with it if now you lose the sun or you have the wind shift, or even worse, the person that owns the battery decides they don't want to pay your afternoon prices, so they pull themselves off the grid and start using their batteries. And so every time you put that kind of variability into the grid, you lower its efficiency, which is a different way to generate more greenhouse gases. So we have had cases where actually adding renewables increases greenhouse gas because it catches it right on the crest. So when you look at how to use software and intelligence and data, the really obvious place to use that is to start moving toward an aggregation of those behind the meter resources and actually make them more palatable to the power company, the grid, by allowing them to be dispatched and allowing them to be of significance. So they don't have to talk to 10,000 homes, they can talk to one aggregator. There's in fact a new FERC order that basically starts to open this up. So we're going to see more and more of this. Now that's a very complex mathematical question, because you can't just let everybody put their own control system on every building that sits outside the meter and expect to have any kind of coordinated response to disturbances. I was having lunch with our own CEO of our ISO here in California, and someone asked him, what would you like to see most in the world? And he immediately answered, I'd like to see the buildings start to respond when I'm in trouble before I send any marketing signals out. So we're really getting down to where if you want to control down to the speed that the power systems need it, there's a trade-off between efficiency, intelligence, and the actual generation.
I'd like to move into connectivity and community. You know, cross industry with global warming, it all leads to the need for connectivity and community. Tell me about your community vision and the importance of this for a connected country or even a connected kingdom, the exchange of information and how we get there.
So let me stay with my example of distributed energy resources that I was on a second ago.
Perfect.
So when you look at the communication, you have more than the communication issue. You also have the data ownership issue. So one of the issues we have is that the generation, when you're looking at distributed energy resources, the generation and the loads, the data don't belong to the power company. They belong to the user. And so if you're looking at the metering applications in the normal grid, maybe 10% of your meters are what are called commercial and industrial meters, but that's 50% of your load. So part of the coordination across ownership means that you have to start maintaining within your infrastructure who owns the data, who can see it, what it can be used for, and things such as that, because you're getting to a scope where you can't just let every company in a grid territory be able to see everybody else's data. So we have a lot of challenges to do it. We call that community systems because they're looking at multiple owners and multiple participants in a much larger problem. And that goes to your issue on communication. How large is the problem? The main tenet on that is that if you're trying to solve a problem, the actual scope of data you need is set by physics. It's not set by what data you happen to have or what system has what. If we start looking at trying to better manage the grid, the scope of data is immense. That means that every power plant affects the grid in its own way. Every load affects the grid in its own way. And all those effects are communicated to everybody else through the power system itself. The same is true on the internet, the same is true on the atmosphere. So if you actually looked at the scope of the problem for managing our grid, you're now talking a much larger system than you ever would have thought before. And fortunately, the technology for doing these ultra large systems is coming along very nicely. So we're getting bigger and bigger in these systems, and we need to be ready to handle systems of much wider scope. And now you start to talk about why do you need an infrastructure? You really can't put that kind of a data management in an application. You have to really address the needs of the actual suite of problems that you're going to start solving. You also have to make sure that things like AI, which is ideally suited for handling large volumes of data, you have to make provision for them to be used. I heard it once said that the average person has a ability to handle transient data of about 5 hertz, 5 times a second. We're talking about problems that are more like 1 million times a second.
Wow. John, any points on that before I move on to the next question?
I think the part to add from an information standpoint, you could just take a very simple problem like EV charging, and you could look at all the different collaborators around that problem. Like, for example, the EV owner themselves, they want to get access to their EV charging data. The EV charger manufacturer may want to get access to that data. The car manufacturer may want to get access to that data. The battery supplier to the car wants access to that data. And that's before we even get talking about aggregators of energy, the utility company, and the players in the market. So really how you're going to slice and dice this data and share it amongst the community is a very large problem.
Thanks, John. Really great add-on. Yes, Pat?
Yes, I'd like to add to that. That brings up a second point that I forgot to mention, is that you can't really think that every charge is going to be the same, every car is going to be the same, every battery is going to be the same. There's going to be this multiplicity of vendors out there that need to attach to this infrastructure and provide their value to it. This means that the infrastructure itself has to develop a reputation and a trust for a neutral operation. Like early internet, it has to be neutral so everyone is treated equally, so that you don't spawn multiple channels of communication, which is even harder to handle.
Okay, I wanted to move on for a second. At OSIsoft, we believe people with data can transform their world. What is needed to do this? How does providing people with data allow them to address global warming?
Well, the main thing about having the data is that it tells you what actions to take on. Now, some of those actions will be, in fact, executed by people. Other actions will be executed automatically. But without good, solid, reliable data, you can't do that. So you have to go back to the philosophy of I'm going to build my whatever power generation grid, etc., so I can be standalone and I don't care if anybody else is running or not, because you actually have to care because of this communication between all the entities. And so where the people are empowered is that if you know what actions to take, then you can take actions on them. If you can see ways of predicting when you have to take action, you can actually implement those actions automatically. In an autonomous vehicle, if you're going to hit something, you stop. And what the AI will bring to that will bring a more heuristic design where you can more closely mimic the actual people doing it, but far more rapidly and able to handle the kind of data volumes they have to deal with.
Okay, great. Empowering the people with data. Excellent. So the one final concept that I wanted to talk with you about, the U.S. Department of Energy, through their Office of Electricity, they came out with the North American Energy Resilience Model, or NARMS. I think it was back in July of last year, 2019. If the U.S. government had a situational awareness center of all of the energy in the nation, including electrical, oil, gas, water, what would that look like? And how would the data in our customer systems help?
It looks almost like what we would call a center of reliability combined with a remote operating center, combined with an operating center, and et cetera. It's basically a center that brings together all this information to where you can supply it to different people / apps / whatever. And I think if they went in and toured some of the ISOs that we have in the US, they would see very similar systems operating together today, but only for power, for electrical power.
Right.
But if then they walked over to the gas company, they would see a similar one for gas. And then if they looked at some of these vendor-based remote maintenance systems, they would see something based on equipment. The issue is that if you really want to have sustainability, you need all of the above. And so that's really, again, where having a real robust data infrastructure helps you a lot, because anything that needs the data can sign in to get the data it needs to do its function. And the data is not lost in these silos where it's been processed and ready to go. Great.
Anything to add on that, John?
Yeah, I think when you look across all the industries that you mentioned there, there are a significant number of customers that are capturing that data already. And if they could just readily make that available to the center, cross their boundary into the center's boundary, I think that would open up a lot more opportunity that way, and do it in a very easy way to integrate. A lot of problems with large systems is the integration components. But given the fact that a lot of these leading industries are already our customers, that would allow them to bring that data in very easily. And then you could worry about the remaining data to bring in a more difficult way.
I would point out, too, if I could, that really emphasizes a known aspect of data that perhaps isn't that obvious, and that is data is the only resource that the more people that consume it, the more valuable it gets.
It's one
And
of my
so by
favorite
having the ability to share actually has a lot more people consuming the same data and increasing its value.
Absolutely. Yeah, we've been talking recently about the collective impact of our broad customer base and the amazing and immense savings on water and efficiency. So thank you so much, Pat. Thanks so much for joining us, and I really look forward to continuing the conversation. Thanks, John, as well. Thank you.